Let's jump right into this explainer and demystify the ray optics phenomena you absolutely have to master for the IIT JEE physics exam. I know. Ray optics can feel, well, kind of daunting, right? All those formulas, the endless ray diagrams, but today we're going to break the whole shebang down visually, step by step, so you walk away with total clarity. Imagine stepping into an advanced optics lab. You can literally see the tangible, dynamic nature of manipulating lasers and light paths here. This isn't just textbook theory we're talking about. It's the actual physical reality of how our universe operates. And honestly, for your IIT JEE prep, the stakes are just as high as they are in a real lab like this. Mastering these exact concepts, that's the secret sauce that separates a good score from an absolutely phenomenal one. Which kind of forces us to ask a pretty profound question, doesn't it? How do we actually bend reality by controlling light? That's the core journey we're going on today. Every single mirror, every lens, every equation you grind through, they are literally just tools. Tools designed to predict and control exactly how a light beam behaves. So here is our visual syllabus for today's explainer. 1. The rules of reflection. 2. Mastering spherical mirrors. 3. Refraction and Snell's law. 4. Lenses, prisms, and dispersion. 5. Instruments and fiber optics. And finally, 6. Mapping out your IIT JEE journey.
All right, Section 1, the rules of reflection, where it all begins.
Just look at the strict, almost beautiful geometrical symmetry here. It's like the universe's most perfect game of billiards. When that incident red laser hits a flat mirror, it doesn't just bounce off randomly, no way. The angle of incidence, which remember is always measured perfectly from the normal line, exactly, and I mean exactly, equals the angle of reflection. Plus, the incident ray, the reflected ray, and that normal line, they all have to live in the exact same plane. It's simple, it's strict, and it forms the absolute bedrock for everything else we're going to do.
Moving on to Section 2, mastering spherical mirrors, curving the light. Now, check out the incredible contrast in how we can manipulate these beams. Over on the left, you've got a concave mirror. Notice how it grabs those parallel green laser beams and converges them down to a very real, specific focal point. But on the right side, the convex mirror, it does the exact opposite. It takes those same beams and diverges them, scattering them out as if they were coming from some imaginary virtual focal point hidden behind the mirror. Getting this physical difference straight in your head is absolutely crucial for drawing your ray diagrams correctly on exam day. So the real trick here is anchoring those physical ray behaviors to the math you actually need for your calculations. Enter the mirror formula. 1 over the focal length equals 1 over the image distance plus 1 over the object distance. Whenever you hit a curved mirror problem on the IIT JEE, this equation right here is going to be your best friend. But listen, mastering this formula is maybe 10% memorization and 90% getting your sign conventions right. Seriously, don't mess up your pluses and minuses. And this completely brings that math to life. Imagine actually being in the lab, physically calculating those exact image and object distances to figure out your magnification. Whether an image pops up as real or virtual, whether it's hugely magnified or tiny and reduced, all of that depends entirely on where your object sits relative to the focal point. You've got to train your brain to visualize the math actually playing out in the physical world. Okay, Section 3, Refraction and Snell's law, crossing boundaries. Let's track this incident ray as it travels through a multimedia refraction cell. It starts off cruising through the air, right? Then, bam, it hits the water. Now, light actually slows down by a whopping 25% in water, which forces the ray to bend inward toward the normal. After that, it hits crown glass, which is an even denser medium with a refractive index of 1.520, and it bends even further. So as the medium's density shifts, the speed of light shifts with it, causing this incredibly precise alteration of the angle. Now, the exact angle of that bend isn't random, it's dictated by Snell's law. The refractive index of the first medium times the sine of the angle of incidence perfectly equals the refractive index of the second medium times the sine of the angle of refraction. The mathematical relationship between these numbers is honestly just beautifully rigid. If you're sitting in the exam hall and you know 3 of these variables, boom, you can effortlessly unlock the 4th. So why does all this matter outside of a textbook? Well, because manipulating Snell's law allows for this wild phenomenon called total internal reflection. See, when light tries to move from a denser medium out into a rarer one, but hits it at an angle greater than the critical angle, it doesn't refract out. Instead, it reflects perfectly on the inside. This single concept is the physical glowing backbone of our entire global fiber optic internet. I mean, think about it. This very physics concept is literally what allows you to stream this explainer right now. How cool is that? Moving to section 4, lenses, prisms, and dispersion. Sculpting beams. Now, these transparent lenses, they behave a lot like the spherical mirrors we just talked about, but with a twist. They use refraction instead of reflection. The convex lens, the one that's thicker in the middle, actively bends those beautifully colored rays together until they hit a very real focal point. Meanwhile, the concave lens, which is thinner in the middle, basically forces the rays to diverge outwards. Let's just directly contrast these behaviors for a second to really lock this into your memory for problem solving. Convex lenses, they converge light to a real focus. Concave lenses, they diverge light from a virtual focus. Do whatever it takes to commit this dynamic duo to memory because you are constantly going to need to distinguish between them when you're grinding through the thin lens formula. Of course, we absolutely can't talk about sculpting light without bringing up the prism, right? It's the ultimate tool of dispersion. Here's the thing. Different colors of light actually have slightly different wavelengths, which means they travel at slightly different speeds through the glass. And that tiny difference is what causes a single, boring beam of white light to fan out and separate into an absolutely gorgeous, distinct spectrum of colors.
All right, Section 5, Instruments and Fiber Optics, Expanding Human Vision.
Just look at how things like aperture, focal length, and extreme magnification all come together in these advanced optical systems. By cleverly layering objective lenses and eyepieces, we can build microscopes powerful enough to reveal a tiny 0.1 micrometer cell, or flip it around, and we build telescopes that capture light from galaxies millions of light years away. When you study this stuff, you aren't just memorizing formulas. You're literally learning the underlying engineering principles behind human discovery itself.
Finally, Section 6, Your IIT JEE Journey, Synthesizing Knowledge. You really want to treat this roadmap as your absolute blueprint. Step 1, ensure your NCERT foundations are just crystal clear. Step 2, build your concepts, kind of like we did today with these visual associations. Then practice, and practice some more using previous year's questions. Make sure you're taking timed mock tests to build up your exam stamina, meticulously revise any weak spots you find, and above all else, stay incredibly, relentlessly consistent with your study schedule. I want you to hold onto this truth because it's empowering. IIT JEE isn't just a physics and math exam. It is a genuine journey of transformation. The harder you study today, sitting under the light of your desk lamp mastering these laws of optics, the stronger and brighter your tomorrow is going to be. It all comes down to focus, discipline, consistency, and ultimately, success. So, I'll leave you with this final thought to ponder today. How will you take these highly structured, newly organized laws of light and actually use them to engineer your own academic success? The tools are sitting right here in front of you. Now, it's just time to put in the work. If you found this structured explainer helpful in, illuminating ray optics, please go ahead and hit that like button. Drop a comment down below with a specific concept you found the most interesting today. Share this with your study group and definitely make sure you subscribe. I'm going to be right here keeping on breaking down these complex topics so you can keep learning efficiently. Keep up the fantastic work, and I will catch you in the next explainer.